Find the derivative of f of x equal the integral from 1 to e to the x ln of t dt. We will do this using the fundamental theorem of calculus part 1. We state that the derivative with respect to x of the integral from a constant a to x of f of t dt will be f of x. All we do here is that we take the integrand and substitute the upper limit into the function f of t to obtain f of x, but only if the upper limit is a single variable x, not a composite of function. And so in this case, we can think of this as the integral from 1 to u of ln of t dt. And so we would need to rewrite this so that we have a single variable in the upper limit of integration. We did a u substitution here where we let u be e to the x. du with respect to x is therefore ex. We want to take the derivative of f of x with respect to x, but we can't do that using the fundamental theorem of calculus because this is x, but this is not a single variable x. And so we did a u substitution. We can rewrite it as du times du dx of f of x. And usually we write this as d du f of u times du dx. This means that if we were to take the derivative of this with respect to x, then the right hand side is d dx of the integral from 1 to u ln of t dt, and this is d du, the integral from 1 to u ln of t dt times du dx. But this u in the upper limit of integration matches the du, or u in the du in the denominator, so these canceled out, leaving us with ln of u, not t, times du dx. But this is not the answer because there's no u in the original given expression. What is u? u is e to the x, and what is du dx? du dx is e to the x, and so this is x times e to the x, where ln of e collapse and it gives us x. Simply put, if we have a composite of function in the upper limit of integration, the shortcut is that we simply plug this function, the entire function, into the variable where the integrand is. So we plugged e to the x into where t is to end up with ln of ex. And then, because of the chain rule, we would need to multiply the derivative of that upper limit of integration. The derivative of e to the x is e to the x. And that is, if we were to speed it up, we have the derivative of 1 to the e to the x of ln of t dt is ln of e to the x times the derivative of e to the x is e to the x, and this is x times e to the x. So we don't have to do this. But this is the reasoning behind this answer.